Divide by a vector. How would you divide vectors? We're not going to talk about dividing vectors. If you can divide by a scalar though,
Yeah.
because dividing for a scalar would be like timesing, like 1 over, right? So that would be that. So let's do a few vector properties for scalar multiplication. Number one's distributive property. Let's say for any scalar k, where k is a real number, and any vectors u and v. Okay, so for any scalar k, where k is a real number, and any vectors u and v, k times u plus v is ku plus kv. Logical enough? Next, we're going to do two more of the associative and identity property. Associative property says for any scalars a and b, A and B, and they're both A, B, E, R, that's right there. Not sure what that. A, E, R, and B, they're both real numbers. And any vector V. AB times V equals A times B to V. Okay, this doesn't always work out though. You might say this is obvious, Mr. Sadler, life is good. Okay, like I understand this, why are you wasting my time with this? I'll do one more, and then I'll do one that doesn't actually work, that thinks that it could work. And then the final one is the identity property. Which is going to be 1 times V just equals V. Here's what I didn't write on here, but let's say I do something like that. What's that equal? If there's two scalars added together, multiplied by a vector. What would that actually equal? Someone want to take a guess?
KV plus LV.
Works for me. Okay. Now the way to think of it, okay, just think KV plus LV. Let's say you have 2 plus 3 times a vector V. All we're saying that's same as 5V, right? Okay, right? You can do it two ways. You can either call it 5V here, or you can say it as 2V plus 3V, which happens to be 5V. Right? Like that's the same sort of algebra works. Right? So no matter which way you look at it there, that's okay.
What heading is that going in?
That's just sort of, they're not really having logic, I guess would be that, not writing, right? That's, distributive property, I guess you'd call it that. Distributive property would be sort of the subheading difference. Okay, we're going to talk about linear combinations. Now, this is, at this point, is when life gets difficult here, okay? This is, so far we've been straightforward, right? Relatively straightforward, a little bit of trig, a little bit of cosine law. Like the question we did the last 2 days, north 30 degrees east, you should have seen something like that before in math class, I hope.
But it's going to stay the same?
No, we're jumping into the future right now, okay? Or the present, I suppose. We're going to talk about linear combinations of vectors. Okay, all this means is, given two vectors, u and v, and scalars s and t, the quantity SU plus TV is called a linear combination of U and V. The way here, sorry. That is one benefit to be at the back of the classroom, is that you guys can all see the board all the time. And this is where all our proofs are coming in. Now that sounds complicated, but we're just going to, this is a way to write vectors in terms of other vectors, that's all we're doing.
Now, did you do SV and TU?
Yeah, that's fine, yeah. It just all, what I'm saying is though, right, if I select 2u plus 8v, that's a combination of u and v. That's all I'm saying. And it's a linear combination because it's just, they're just coefficients being added to each one. All right, here we go.
What's going to be the purpose? Like, what are we going to apply these concepts?
Right now, proofs. Mathematical proof, that's what we're getting into. Okay, so as far as direct purpose, like we're not going to say this is going to save the world with a brain, right? Like that. But I mean, but yes, this is for, we're getting into mathematical proof. Okay. So example 1 is going to say, write, I'm going to draw my parallel now. So I've made 6 vectors there. That is a parallelogram. Okay? So I've drawn with 6 vectors. I'll draw the 4 corners and then diagonally. Okay, so what I'd like you to do is to write vector A as a linear combination of B and F. Just so we're clear here, okay? F, sorry, I should just make my diagram clear. F just goes from here to here, and E is just going to go from here to here. Okay, just so we're clear on that. Okay, so just so the diagram's clear. So what I want you to do is I want you to write A in terms of B and F. Add up B and F somehow, combine them in some ways. So I want to get, so all basically you're saying is, this is what I want. Add B and F some way in order to make that happen. Can it happen? Yeah. Let's try if I had the swanky iPad. So what I want, if I want, this is the vector I want, to add somehow this and this. Let's make that happen. Can it happen? No. Yes, it can. Okay, well, I'm gonna show you, give you the hint here. Okay, it's not. What, that?
Okay, it's okay. Why?
Okay.
Wait, because you have to do your triangle.
Yeah, totally. Yes.
Okay, so you would bring your B up
Yeah.
to, because there's like the tip of A.
Oh,
So
good.
you bring your B up.
Yes.
And then your F line would go down and complete the triangle.
Yeah. Okay, so what you're going to have to do, good. So I like the way to visualize this. It is going to turn into a triangle like this, okay? F is just from here to here, so how would I call this? 2F, okay? So I'm just going to say then, vector A is the same as 2F. Now, the things I have to change here, and you're going back here, I'm going to have to call that minus B still. Okay? We're assuming, and I should probably put the headings on my, to be more accurate. We should sort of say how things are going. Okay? So vector A is going to go like this. So I have directions on everything. Okay? So what we did is, right, we took F twice, and then went back this way, and thus you get the vector. Right? If you add this plus this, you get this. Is that logical? Yes?
Wait, how did you, why did you subtract B?
Okay, because B is going, I just cheated B, I just told you afterwards B is going this way. Let's go after. So I'm telling you now, right? Do the right hand, then move the B up, that's the thing. So I didn't tell you what direction it was going. But you're saying, if you move the B up here, now. Try it. So if you're going to have here, here's your F. There's F, right? There's 2F. And we're going back there.
Oh.
That's what I'm trying to say in that terms.
Oh, okay.
Well, because if I add this, and if I add this way, well, then you're going. Basically, you're saying,
Why
but.
can't you just, yeah, why can't you put it down there?
Yes, if you can show the A and G are the same, right. So the point is, okay, let's just show here. If you do two, if I do this, plus this, it's not actually, let's try again. It's, if you add it, it'd be going further to the right though, right? That's the thing, for the moving up. Like if you add this and this, technically that's the same thing using the, if you add that and that, right? Technically that's the same as, where we have. Yeah, that should give you the same thing, yes. That should give you this. All right. Am I missing nothing?
I don't understand how they can be equated.
Sorry, let me just slow down here. Sorry, go ahead one more time.
Like I see how we're drawing a triangle and the triangle
Yes.
works out, but how can that equal A?
Well, vector A, like, is physically this. All I'm saying is I want to get back to this original space right there. That's what I want. Find a way to combine the vectors to actually get to that. That's what I'm saying. Okay, so basically, again, you're taking, that's going to be this. There's your 2F. And that right there is going to be your negative B. So that plus
I
that is
thought
going to give you
what
X.
you're asking for is the value of A is
No.
equal to the value of.
No, that's not enough. Yeah.
So why is it 2F?
2F, because 1F, because think, if you do 1F, let's try it again. All I cheated here, F we just said is just from here to here, right? So if you just go from here to here, then you only, that 1F is only going to take you to here. So F wouldn't work, then plus whatever would only be here. You could call like F plus 1/2 or F minus 1/2 B would work as well, right? So if you want to use.
And you would not all of it.
That's true, it wouldn't. Yeah, good call. Good call. You got me all frazzled now here. You got me all frazzled here. Let me slow down. I'm all frazzled. Yes.
Are vectors D and vectors B the same thing?
D and B, yes. But we said here we want B and F to use. You want to use B and F.
If they weren't the same thing, this one gets their
Yeah, exactly. Okay, let's try the next one here. Whoops. That is right. I do use my finger only to do that. Here we go. I want you to write. I'm frazzled. I want you to write A. As a combination of E and F. Of E and F. Well, how am I going to get to A? I want to get to this, right? E looks something like this. That's what I have to do, right? Because what's going to happen is here, very good. A is going to, this is going to be your A here. F is going to be halfway up there. E is going to be back here. Right, so A is just going to equal E plus F. Here we go, letter C. I want you to write vector B as a linear combination of A, E, and F. Vector B is a combination of A, E, and F. There are many different ways you can get this. I should probably come up with a number of ways you can get this. Someone give me an attempt here.
A negative E, no, and then,
Well, the thing is, you don't need to use them all, right? There's like, there's one way, like, you can do it if you want. Like, I'm thinking you can go, right, that's one way to do it, right? So you see what I did there? So I added A, I subtracted E, I added F, and then I subtracted A, right? So what I did was, I did B equals A minus E plus F minus A. You see how I got that, right? Just around the outside? Yeah, the thing is, I can write that in either way. What's A minus A?
0A.
Nothing, okay? So I can just write this as F minus E.
That's what
So if you get B, it's going to be F and then minus E, right?
that's the way I did it, but then I thought that I needed an A value.
No, I didn't mean it. You don't necessarily need it, right? The other way I could have done it, I could have done this minus 2E, right? So it could also be, or B equals A minus 2E.
Oh, and it has to be something.
Yeah, minus 2E. Yeah. So just again, just getting comfortable with this sort of different thinking here.
So you don't have to use all the ones.
No, because technically I could say if, let me rephrase. A linear combination is, technically I should probably write this,
Oh,
right? Because then it's still 0 is an integer, right? So it is technically a linear combination involving F for that bottom one, just have to be 0. So I'll accept they'll be equals A minus 2E, or F minus E plus 0A. I am mean though, why will I not accept this first one? It's not simplified, right? It's not simplified, so.
And you have to write 0, right?
No, that's what you're saying, you don't have to, but people were asking, I thought you'd use all three, right? Technically I am, because that is, by the definition of linear combination, a real, 0 is a real number, right? So that still works. I see people falling asleep here, I apologize. This is what we're doing today, yes.
so you're trying to make a triangle with these again, sort of like.
Not necessarily, yes, you can think of it as a triangle, it doesn't necessarily. Like I was showing with the first one, like you can do it any way you want. To get B, I did an M for the first answer, right? So it doesn't have to be a triangle, right? But that would be a triangle, that would be a triangle. I could have done this thing there, right? So I could have done 2F minus A, would have worked as well. Like there's a whole bunch of ways it could have worked out there for sure.
B, do you have to prove that A equals
No, because you don't even, no. Because we said it's a parallelogram, that was why I didn't actually say that, but it's there. Okay, let's do a little bit more and then we'll talk about what I actually want to get into today.
really important? C also uses A equals.
Okay, this is a little bit of algebra. Oh goodness, not example 2. For any vectors u and v, please put a star mark beside this one. Let me pause my video actually. It's already half an hour, but I'm having a rough day today.